To do our last example in this section. I'm probably glad there's only 3 examples in section 5.3. We're now going to talk about altitude. So earlier in this section we talked about medians, and where medians converge or are concurrent, they form something called a centroid. And we talked about that the last 2 examples. Now we're going to talk about altitudes. An altitude of a triangle, it's a perpendicular segment. So it's not a perpendicular bisector. It's just where you take, you can start at a vertex, and if you can draw a line perpendicular to the side opposite of it, that forms what we call an altitude. An altitude. We've also called that the height of the triangle before. We've used this before. An altitude can be inside, outside, or actually on the triangle itself, just like circumcenters. Circumcenters are like that too, where they can be located inside that triangle if it's acute, outside the triangle if it's obtuse, or on the triangle if it's right. Ortho or altitudes can operate much the same way. Okay, so every triangle is going to have 3 altitudes. You should be able to take each of the vertices and draw an altitude from the vertex to the opposite side from that vertex. And where they converge, that forms something called an orthocenter. Okay, so we got a circumcenter, we have an incenter, we have a centroid, and now we have an orthocenter. And every one of those words has something very common and similar about it, and that's the word center. In some way, shape, or form, the word center is on it. So 2 of them are always located inside the triangle. That would be your incenter as well as your centroid. They're located always inside that triangle. An orthocenter and a circumcenter depends on the situation. Okay, and this one that's graphed to the right here, the orthocenter is actually outside of that triangle. You have one altitude that's inside, so that QY altitude is inside the triangle, but if you start with letter S, S is outside, so that forms SZ forms an altitude, and RX forms an altitude, and where all 3 of these converge at point P, that is what we call an orthocenter of the triangle. So let's look at example 3 and see if we can find the orthocenter of triangle JKL with vertices J, which is located here at -4, 2, K, which is at -2, 6, and then L, which is at 2, 2. So here's our triangle, and those are the vertices. So the first thing you got to do when you're given this information is go ahead and just draw it up there, graph it, get a visual so you can really see it. Now, what's really cool is JL is horizontal. That's cool. Let me write that note down. JL is horizontal. So what that means is the altitude is going to be a vertical line dropping down from the point opposite of JL. Well, the point opposite of JL is point K. So that's really a no-brainer right here. That's easy. They're not always going to be easy like this, guys. There's not always going to be a vertical line or horizontal line that forms your triangle. But if there is one, then it's really, really simple. Okay? So we can see that K to JL forms a vertical line. Okay? And we can name that vertical line. We already know that that vertical line is going to cross through. It looks like x equals -2. So remember, vertical lines always start with x equals. Horizontal lines always start with y equals. So this vertical line's crossing through -2 on the x. All right, well, that's great. That's really helpful. We just need one other altitude, and then I think we've got it figured out. So And it doesn't really matter which one you deal with. I want to show you how to handle the situation when one of your lines actually isn't going to end up being a horizontal line or a vertical line, and it's just at some angled line, and we got to figure out, where do we go from here? So I'm going to select KL, and I want to figure out, how do what line do I draw from, what's my altitude from J to KL? Now to do that, what I want to do is KL, I want to figure out the slope of KL, okay? And your book uses the slope formula, y2 minus y1 over x2 minus x1. If you've graphed it, use rise over run. It is so much easier. So if we go up 1, 2, 3, 4, up 4, that's positive 4. If you go up, that's positive. If you go left, that's negative 1, 2, 3, 4. So we've got 4 over negative 4. That means KL has a slope of negative 1. Now, a perpendicular line is going to be opposite reciprocal, okay? So the perpendicular slope would then be the opposite reciprocal of negative 1, which is what? What would be the opposite reciprocal? You're right, positive 1. So that means starting at point J, I need to move from point J, I'm going to use rise over run, I'm going to go up 1, right 1, and figure out what my line is, okay? So I go up 1, right 1, okay? Up 1, right 1, up 1, right 1. And so here's my line. And so here I have an altitude here and here. And my first altitude was a vertical line because vertical lines are always perpendicular to horizontal lines. So that was not hard. I didn't really have to figure out anything terribly difficult there. But what made it a little bit more challenging was I did have to figure out the slope of KL, find the opposite reciprocal of that, and then start with the point opposite of that segment KL, which was point J, and use my slope to kind of construct where I thought that point of intersection would lie, okay? Now, because it happened at a place where the grid intersection occurred, it's really easy to visualize where it actually crisscrossed. That may not always be true, okay? So I need to prepare your mind. Just because you can calculate the slope and use opposite reciprocals, you may not be able to tell from the graph, especially if it doesn't crisscross at a grid intersection, you may not be able to see precisely where that number is, where that point of intersection is, okay? Especially if it's not at a grid intersection. So what you may want to do is algebraically kind of back up what you just found. So we know point J is on our line, and point J is located at negative 4, 2. And we just figured out that the slope of our perpendicular line should be positive 1. And so you could plug in the point slope form. Y minus 2 is equal to 1 times x plus 4. Sorry, I wrote m. I was thinking m while I was writing the 1, so I apologize. So y minus 2 equals 1 times x minus a negative 4, or x plus 4. So I've got y minus 2 is equal to x plus 4. Add 2 to each side. And so the slope or the equation of my perpendicular line that's running from point J over to KL, the equation to that is y equals x plus 6. So you know the equation of this line, you know the equation of your vertical line, and so you should be able to easily figure out, it's not x equals 2, it's x equals negative 2. You should be able to easily figure out where that point of intersection is just from those two equations. So they're already telling you what x is equal to. So we know that the point of intersection, x is negative 2. We do know that beyond the shadow of a doubt because of the vertical line. It tells you x equals 2. And then to find the y, you're going to substitute -2 and plug that in for x. And you'll have -2 plus 6, which is 4. And so here's your orthocenter right there. It's not necessary to go L to JK necessarily. You can to make sure your numbers are right, but it's not essential that you do that. If you do 2 of the 3 and find out where they intersect, you're golden. You should be really good there. All right, so that's the orthocenter. It's located at -2, 4. You can either look at the graph, not necessarily that won't be there when you solve a problem, but you could look at your graph. If it crisscrosses at a grid intersection, use the graph. If it doesn't, then go back and use your algebra skills here and plug in numbers that you know. Plug in a point and the slope into point-slope form. Find that equation of your line and then figure it out. You may have to substitute or eliminate, and you have to tie in some of these algebra skills that you've learned from last year in order to figure this out. This is, I hope, one of the easier ones in that you are able to conceptualize this pretty easily. All right, well, that's it. You just found an orthocenter. Yay, you. If you have questions, let's talk about those in class tomorrow.